Welcome to page 1 of your probability packet. On this packet, for the first page, we're going to be using the probability scale. Let's take a moment and construct that probability scale at the top of your page. Remember, it stretches from 0 to 1. Please record that at the top of your page. And also note that if you have a probability of 0, the event is impossible. And if you have a probability of 1, your event is certain. It absolutely must occur. In the middle, you have an even chance. So we label this with the fraction 1/2. But more importantly, when it comes to probability rates, we're going to convert that to a decimal. 1 divided by 2 gives us the decimal equivalent of 0.5, or add a 0, 0.50. If we cut that in half, the probability rate is 0.25, and if we cut the upper half in half, our probability rate is 0.75. We're going to use decimals most of the time to compare probabilities. But let's get started with number 1. Which of the following probabilities is very likely to occur? Well, let's see where they lie on the probability scale. 12 hundredths is about here. That's a weak chance. 1.3 is not even on the probability scale. 0.89 is about here. And 9 hundredths, well, that's down here. So clearly, this has the strongest chance of occurring. Let's move on to number 2. Based on a weather report, the probability that it will rain tomorrow is 0.13. Which word describes the likelihood that it will rain tomorrow? Well, where does that lie on the probability scale? It's about here, 0.13. Well, it's not certain because it doesn't have a probability of 1. It's not impossible. So decide. Is there a strong chance? Is it likely? Or is it close to 0 and highly unlikely? D. And lastly, for number 3, it states, Sarah is playing a board game. The probability that Sarah will score a point on her next turn is 1/3. Which statement describes the probability that Sarah will score a point on her next turn? Well, again, take 1/3 and convert it to a decimal. 1 divided by 3 on your calculator. It gives you the decimal equivalent of repeating 3, which falls here on the probability scale. So is it likely, unlikely? If we had a probability of 1, it would be certain, so it's not that. And if we had a probability of 0, it would be impossible, so it's certainly not that. Since it falls closer to 0 than 1, we would call this highly unlikely. So there's a few questions that address the probability scale. Make sure you have all the notes, and let's move on to the 4th question on this page together, where again, we're going to be converting our probabilities into decimals to make an easy comparison. Let's take a look at number 4. For number 4, it states, Leanne collects data throughout the basketball season and uses these data to determine the probability of different teams playing in the league championship game. The probabilities for her 4 favorite teams are listed below. Now, we're given the probabilities in fraction form, and it's very difficult to compare if they're in fraction form. But grab your calculator. We're going to divide and turn each of these into the decimal probability. For the first one, the tigers, punch in 2 divided by 3. You should get 0.6666 repeating. For the redbirds, punch in 4 divided by 8. You should get 0.8, and I'll even add a few zeros. For the bulldog, punch in 3 divided by 8. You should get 0.375. And lastly, we should know that 1/2 is equal to 0.5, but I'll add a couple zeros for comparison's sake. As we compare these teams, which is least likely to win? Well, let's start in the tens place. This is a 6, this is an 8, this is a 3, and this is a 5. The team with the least likely chance is the Bulldogs, letter C. Let's move on to page 2. Let's take a look at calculating some probabilities. And again, it's going to be very important to turn all your fractional amounts into decimals as we compare. Let's take a look at number 5 together. It states, a passenger train has tickets available for 12 window seats and 8 aisle seats. The next person to buy a ticket will randomly be assigned one of those seats. What is the probability that the next person will be assigned an aisle seat? Well, the best thing to do with this information is to create a little table. We know 12 people get assigned to a window seat, and 8 people get assigned to an aisle seat. And for any probability, we need a total. The total number is 20. So make a little list with a total. Now we're going to see what's the probability that someone will get assigned an aisle seat. Well, that's the part over total, or 8/20. Now we could reduce this with our fraction key, but we're going to divide it, 8 divided by 20, and turn it into the decimal 0.4. That's our probability rate as a decimal. Then we're going to take each one of our fractions and convert those to their decimal equivalent. One of those answers will match with 0.4. Start with our first fraction. Punch in 1 divided by 8. You should get the decimal equivalent, 0.125. Well, that doesn't match. Do the next one. 2 divided by 5. And in this case, you get 0.4. This is the answer. Let's move on to number 6 and look at the table we have been given. It states, a cereal company puts colored rings in each box of cereal. There are 6 different colors. The colors of the rings in each of 50 boxes are shown at the table below. Well, we're given all the parts, but we typically need a total. So take a moment and add up and get the total number of rings represented. You should see that our total is 50. Now, it says based on the data, what is the probability, you should think fraction to start, that the next cereal box will contain blue or yellow rings. So the probability on a single draw of blue or yellow. Well, we know our total is 50, and the part that's yellow, and blue must be added together, we're talking about 20 out of 50. But divide that and convert it to its decimal equivalent. There's a 0.4 or 0.40 chance that we will get that, which of course is a 40% chance. Take a look at the fractions you've been given and convert them to their decimal equivalent. Divide each one, such as 1 divided by 6, and see which one's equal or equivalent to 40%. In this case, we get 0.1666 repeating. Clearly, that's not equivalent. Punch in 2 divided by 5 for the next choice. You can see that we get 0.4 here. Clearly, this is the correct probability. So remember, when you hear probability, think fraction, but then convert it to its decimal equivalent. It's much easier to use. Let's go on to the next problem. For number 7, it states a spinner is divided into 4 colors that are not equal in size: red, blue, purple, and orange. The arrow on the spinner is spun several times. Here are the results: 15 red, 24 blue, clearly that's most likely, 12 purple, and only 9 orange. Clearly that's the least likely outcome. Whenever you get these results, though, you're going to want to take and find a total. When we're calculating probability, it's always part over total. So as we add up 15 plus 24 plus 12 plus 9, we can see that there were 60 spins total. Now let's read. The arrow on the spinner will be spun one more time. What is the probability the arrow will land on purple? So, you hear probability, you should think fraction at first. So, for purple, we have a 12 out of 60 chance. But let's take that and convert it to its decimal equivalent. Punch in 12 divided by 60. You should get the decimal equivalent 0.2 or 0.20. We know that's a 20% chance. Now convert each of these to their decimal equivalent to find out which one matches purple. For example, letter A, 1 divided by 4 gives us a decimal rate of 0.25. Well, that's not it. Letter B, 1 divided by 5. That gives us a decimal rate of 0.2 or 0.20. Clearly, letter B is correct. Let's turn the page and move on. Make sure you're copying down all the notes. Let's take a look at page 3. We're going to start with number 8. It states the owner of a small store knows that last week 54 customers paid with cash, 42 paid with a debit card, and 153 paid with a credit card. Based on the number of customers from last week, which fraction is closest to the probability that the next person will pay with cash? So it's not going to be exact, it's going to be close. Well, anytime you get information like this, make a list with a total. 54 paid with cash. Please copy these notes. 42 paid with a debit card, and 153 paid with a credit card. We'll take a moment and get the total. Use your calculator to add up all the parts, and you should get 249 people total. Now we're interested in the part that pays with cash out of 249. So what's the probability of getting cash? Well, put 54 out of 249 and divide and convert that to its decimal equivalent. 54 divided by 248 gives us 249 gives us 0.216 and so on. So we're looking for a probability that comes close to this. So again, grab your calculator and convert all these fractions to their decimal equivalents. Let's start with letter A. 1 divided by 5 gives you 0.2, and we can even add a 0 or 2 if needed for comparison. That seems pretty close, but let's try the next one. 1 divided by 4. Well, it gives us 0.25, and you may add a 0 for comparison's sake. So right now it still seems to be letter A that it's closest to. The next one, 1 divided by 3, gives you 0.3 repeating. And this last one, 0.5, and you can add some zeros. They're out. Clearly, it's letter A is closest to what we're given. So the key is make a list, find a total, and calculate your probability. Let's try the next one. Carrie has a bag containing white and yellow marbles. Carrie randomly selects one of the marbles from the bags and records the results for the first 65 selections. 41 times she picked a white marble and 24 times she picked a yellow. Based on the results, what is the probability, you should think fraction, that the next marble will be white? Round the percent to the nearest whole percent. Again, let's make a list off to the side. 41 times we saw a white being selected, and 24 times we saw a yellow being selected. That's a total of 65. When it comes to probability, remember it's part over total. So what's the probability of getting a white marble? Well, that's 41 over 65. But we're going to convert that to its decimal equivalent, 41 divided by 65, and you get 0.6307, etc. And when we scoop twice and convert that to a percentage, this is certainly closest to choice D, rounded to the nearest whole percent. Let's move on to the next two, number 10 and number 11. Number 10, a company sells artwork using a website. The information about the number of people that visited the website and the number of pieces of artwork purchased on a single day is listed below. 117 people did not purchase, 24 purchased one piece, and 9 people purchased more than one piece. Based on the data from the day, what is the probability, and you should think fraction, that the next person that visits the website will purchase more than one piece of artwork? When you're asked for probability, you automatically think about a fraction and, of course, part over total. We want to find the probability that the next person will buy more than one piece of artwork. We know that 9, that's our part, bought more than one piece. But what's our total? We need part over total. So we're going to take and total up all our parts. 117 bought none. 24 bought one piece of artwork, and 9 bought more than one. Take a moment and add up those parts. Get a total. Use your calculator and add those parts. You should have gotten a total of 150. Now, as we look at the other fractions and compare, we can see that the answer can't be found. So the best way to work with this, rather than reducing, is to convert all of these to decimal form and find out which probability matches. So grab your calculator and punch in 9 divided by 150 and get the decimal rate. We get a decimal probability of 0.06. Okay, go through each one of the answers and see which one matches 0.06. For the first one, convert that to the decimal equivalent. Punch in 1 divided by 9 and hit equals. Well, we get repeating 1. Clearly, that's not a match. 9 divided by itself would give you the probability of 1. Clearly, that's not a match. Punch in letter C, 3 divided by 50. And what we get here is 0.06. This is the probability we're looking for. Remember, whenever you're in fraction form, when it comes to probability, convert everything into decimal form. It's so much easier to work with. Okay, let's take a look at number 11. For number 11, we're going to calculate another probability. We have to create a list with all of our parts, and we're going to take a total as well. Let's read. A store owner made a list of the number of greeting cards sold last month. 167 were thank you cards, 285 were birthday cards, and 56 were blank. Based on this data, which is the closest probability that the next customer will buy a blank card? Take a moment and make a list of all the parts. 167 thank yous, 285 birthday cards, and 56 blank. Those are your parts. Now add those up and get a total. Use your calculator. You should get a total of 508 cards. Now, what's the probability of getting a blank card? Well, we have to take part and put it over the total. We're going to take 56 divided by 508 and convert it to its decimal equivalent. Pick up your calculator and take 56 divided by 508. Now remember, we're looking for the closest to this particular probability. And if you look through your choices, you should see it's letter A. Now let's turn the page and work on more probability. On this page, we are going to use probabilities to make predictions. We're going to skip problem 12 and move on to problem 13. In number 13, it states a spinner with 7 equal size sections was used to play a game. It was used 250 times in the first game. Of those 250 times, the arrow landed on section 7 35 times. If the same spinner was used 150 times in the second game, how many times did the spinner most likely land on section 7? Well, clearly less than 35 times. But let's make a prediction. Let's start by calculating a probability or a rate. Based on the first game, the probability of getting section 7 out of 250 spins was 35 times out of 250. Now grab your calculators and divide. Get a decimal rate. That's always so useful. We can see that it occurred 0.14, or as a percentage, 14% of the time. So the same should be true of the next game. As we draw a tape diagram to make our prediction, we know we're only going to spin a total of 150 times. 14% of those times, section 7 should show up, or 0.14. That's our rate we're going to use. So here we go. R times T equals P. 0.14, or 14% of the time, of 150 spins. Please punch that into your calculator. 0.14 times 150. It should give you whatever 14% is. And in this case, it's 21. Let's make some more predictions where number 1, we get the rate in decimal form, and then number 2, we use our formula and tape diagram to make that prediction. Number 14 states, the results for a survey of 120 people who were selected randomly are listed below. 60 people have cell phone plan X, 36 have plan Y, and 24 do not have a cell phone. So we know the total is 120. If the total population was 360, based on the data, what is the best approximation or prediction for that students who have cell phone plan with company Y? Well, first, let's get our rate. The probability of picking company Y out of 120, we see that that's 36 students. So get your rate as a decimal. Punch into your calculator 36 divided by 120. We get 0.30, or 30% of the group should have cell phone company Y. So in step 2, let's make a prediction and apply that to 380 people. 30% of that group should have cell phone company Y as well. So R times T equals P. Use 0.30 times 380 people total. 0.30 times 380. Find out what 30% of the group is. You should get 114, which is choice A. Again, for a prediction, we need the rate, and then we go to the tape diagram in step 2. Let's do problem number 15 and make a prediction. At a store, customers are randomly selected to participate in a survey. On Friday, there were 500 total customers at the store. Of those, 90 participated in the survey. On Saturday, the store manager expects 700 customers in the store. If the probability of being selected to participate in the survey on Saturday is the same as it was on Friday, how many customers will be selected to participate in the survey? We need to make a prediction. First, let's get a rate. The probability of being selected for the survey on the first day was out of 500 people total, 90 were chosen. But we want a decimal rate. 90 divided by 500 means the rate is 0.18, or basically 18% of the customers were selected. So it should be true that on Saturday, of those 700 that are expected to be at the store, please draw a tape diagram, 18% should be expected to be a part of the survey, or 0.18. So use your formula, R times T equals P, and figure out what 18% of 700 is. 0.18 times 700. We would predict or expect 126 people to be selected for the survey on Saturday. Now let's turn to the final page and look at some tree diagrams. When you're asked for the total number of choices or possible outcomes, you might think of tree diagrams. Let's take a look at our ice cream menu. How many different choices or combinations of size, flavor, and topping can be made from the menu? Well, in our first pool of elements, we have 3. In our second pool of elements for flavors, we also have 3. And for our toppings, we also have 3. Take your elements and multiply using the fundamental counting principle. 3 times 3 is 9, times 3 is 27. There are 27 possible outcomes. We don't have to do a tree diagram for that. But let's take a look at the next one. It says Henry has a fair number pyramid with 4 faces and a spinner with 3 equal colors. How many possible outcomes are there? Well, in this pool of elements, you could get a 1, a 2, a 3, or a 4. There are 4 there. For the spinner, as you look at the pool of elements, you could get 3. 4 times 3 means there are 12 combinations. How many outcomes? There are 12. And finally, let's look at problem 18. For problem 18, we're actually going to make a tree diagram. It says which tree diagram shows all the possible outcomes for tossing a coin, that's your first event, and rolling a fair number pyramid with 4 sides. Well, for our first event, we're going to be flipping a coin. So in our pool of elements, we could get a heads or a tails. And our second is going to be rolling a pyramid. That pyramid has a 1, or you could roll a 2, a 3, or a 4. There are 2 outcomes here and 4 elements here. 2 times 4 means there are 8 possible outcomes. But let's draw a tree diagram to display those. You could get, as we look at our first pull, heads or tails. Once you're done with that, you could get heads with a 1, heads with a 2, heads with a 3, or heads with a 4. And the same is true for tails. Tails with a 1, tails rolling a 2, tails rolling a 3, or tails with a 4. Now, as you look at your tree diagrams given below or to the side, you can see the one that displays the 8 possible outcomes is choice D. This concludes your video on probability. Make sure you have all the notes.